Let us talk about reversible reactions. These are reactions that can proceed in either direction. Reaction that can proceed in either directions by change of condition. For example, when ice is subjected to heat, for example, ice subjected to heat, it melts to give water. And again, when water is cooled, it gives ice. It cools to give ice. And the first process where we have heating is called melting. And the cooling one, water back to ice, is what we call freezing. It therefore implies that this reaction is reversible, meaning products can still change back to reactants on changing the condition of the reaction. You've seen in the first case, it is heating, that is from reactants to products, and when the products are cooled, then we get back the reactants. So such reaction is normally referred to as a reversible reaction. Another example of a reversible reaction is nitrogen 4 oxide gas will give a liquid nitrogen, that is when cooled. That is nitrogen dinitrogen tetraoxide, which is in liquid state. And when that is heated, then it gives back the nitrogen 4 oxide gas. Another case is copper 2 sulfate, that is anhydrous plus water. I will give the hydrated copper 2 sulfate. And when this hydrated copper 2 sulfate is heated, it loses the water of crystallization and gives back then anhydrous copper 2 sulfate. So there are several reversible reactions whereby on changing the condition, then we get back to the reactants that is coming now from products back to reactants. Several chemical reactions can be reversed, and this will totally depend on the condition. Like we have talked over, when hydrated copper 2 sulfate crystals are heated, the white copper 2 sulfate powder forms. That is copper 2 sulfate that is hydrated. In fact, it has 5 molecules of water. When you heat this, you get copper 2 sulfate solid plus the 5 water molecules. So this is liquid, this is solid. The hydrated copper 2 sulfate, that is blue crystals, and the anhydrous, that is white crystals. Now, when water is added, that is now water added to the anhydrous copper 2 sulfate, that is white, will get back the hydrated copper 2 sulfate. Remember, this condition is not reversed by cooling. It is simply adding water to the anhydrous, then that gives hydrated copper 2 sulfate, that is solid, which is blue in color. So that is a good example of a reversible reaction. When solid ammonium chloride is heated in a test tube, it decomposes into ammonia and hydrogen chloride gas, which when reacted again form solid ammonium chloride. And that is realized by the fact that ammonium chloride sublimes. So when it's heated, it gets to gases, it forms the gases, and when the gases cool, when the gases recombine, then they give back the ammonium chloride. Let us have, like this is a test tube containing ammonium chloride that is heated, solid. So that will give ammonium chloride sublimate. So that is that. So that is now the ammonium chloride sublimate. Recall, ammonium chloride sublimes when heated, and when cooled, it deposits back as the solid ammonium chloride. So we are saying that the reaction is ammonium chloride heated forms ammonia gas and hydrogen chloride gas, and when it's cooled, the two gases formed recombine and give back ammonium chloride. In reversible reactions, if the reaction proceeds from left to right, then that is a forward reaction. Left to right, that is forward reaction. Like the heating cases that we are talking about, that is forward reaction. Then right to left, that is called now backward reaction. Like for instance, ammonia gas, combining with hydrogen chloride gas to give ammonium chloride, that is a backward reaction, while ammonium chloride heated to break down into ammonia and hydrogen chloride. That is now what we call a forward reaction. That is all about reversible reaction.